You're listening to the Knowledge Archives podcast. Welcome to the Knowledge Archives podcast. We're a group of students on a mission to learn from as many different disciplines of knowledge as possible. I'm your host, Madhav Malhotra, and today I'm pleased to be joined by Dr. Niko Wanders, an assistant professor studying hydrological extremes at Utrecht University in the Netherlands. His research focuses on studying extreme effects of climate change, like droughts and floods especially. And thank you for joining me today. I really appreciate you taking the time, and I'm very much looking forward to learning more about this increasingly important issue. And before we got started with the specifics of all the details, I would love to just hear a little bit more about yourself, your story, and how you got started in this area of work.
I started actually my career in the Netherlands in Wageningen we're starting an MSc project on droughts and climate change. I think that was in 2009, 2010. So it was not the hottest topic at the time. But what intrigued me about droughts was that we don't fully understand how they develop, or we didn't fully understand how they develop, and they're a slow-moving disaster. It's not like a flood that comes clearly from a lot of rain, but it's more mystery, in interaction with precipitation, evaporation, how people use water. So then went to Utrecht to do a PhD, mostly actually on floods, because in the Netherlands we do a lot of flood research. And then I moved to Princeton University for I think 2 years to work on a seasonal drought forecasting system for Africa. So that was I learned a lot there and also a lot of skills. And then I got this position here in Utrecht, where they asked me to continue my passion for droughts and working on this and with a focus on climate change. And that's what I've been doing the last 3.5 years, I guess, by now. And yeah, it's been an exciting journey.
Yeah, I think it's really incredible to hear about the diversity of experiences when it comes to especially how global this problem is. And regarding that, I thought that first of all, it would be great to get a little bit of context as to what the factors that we're actually studying are.
Yeah, so if you the factors that influence, of course, the amount of precipitation, the amount of evaporation, but also the amount of water use that people do. And I think that's long been something that's not really well recognized. I mean, we think of drought as a natural phenomena, but more and more in a man-made world, humans play a key role. So what you see there is that what people use water and how extensively they use it, and also for which purposes actually matters quite a lot. And if you move around the world, places around the world are so different in terms of what the impact is of a drought, but also how they happen. So starting in my own country, it's not known as a dry land, the Netherlands. It has major river systems. It's known for fighting floods. There's a lot of water, but it also means we use a lot of water on the other hand. So we're quite dependent on that water that's here. And that also means that if there's a drought, that the consequences can be larger, but they're mostly economic. Same if you go to the US or Canada for that matter. Basically, the consequences are mostly economic. There's a lot of water use depending on the regions, especially for agriculture, way more than you do in the Netherlands. But there's also drier regions. And there, if you see in the drier regions, you might have more of a seasonality and water availability. So there's a lot of water in winter available, but there's not that much in summer. And what you see then is that people have to manage the water, store the water, and then use it in summer. And what typically happens in those cases, if you have a deficit in winter precipitation, so not enough winter precipitation, yeah, then the summer becomes difficult to manage. We've seen nice examples, or nice between quotes, in California, where that's clearly happened with 3 dry summers in a row. But then the more impactful part of the drought research, if you go to countries like Africa, I was visiting Jordan, I think 2 years ago. If you see the problems there related to drought, clearly there's not as much rain as we have here in the Netherlands or large parts of the world, but people are very much aware of the impact of droughts. But the impacts can be gigantic as well, and not only on the economic scale, crop losses, there can be forced migration, even starvation and food aid and things like that can happen. And I think that's the part where it really matters on the things we do. But it's also the most challenging regions because the dry lands are typically known for not having a lot of rain and other problems as well related to that. So there's also a large body of literature around conflicts and droughts. The drought problem is like, it's one word, but depending on the region you are, it's a different beast. And I think it's very good to recognize that. So for the Dutch, we think about drought as not being something really impactful. It costs us a lot of money in case it happens, but it doesn't kill people. We fear floods, but in other countries, drought is definitely the major issue, especially on the climate change where we go to a situation with more extremes, looking at more floods, more droughts at the same time, and also shifts in precipitation distributions around the season, so more winter or more summer precipitation, giving us additional challenges. And I think that's really, again, between quotes, but exciting part about the field, that there's a lot unknown, and it has a lot of impact in the coming decades to come. And I think it's key that we as scientists try to unravel some of that puzzle and try to see if we can find solutions, because building infrastructure that can deal with those drought situations, it's not something you can do in 2 days. It's a decadal process. It's take 10 years or more, and also a change of mindsets. Yeah, drought is not just one thing. It depends on where you are.
I think it's great to hear about all of that context. And something that sparked my curiosity at the end there was about the infrastructure that you mentioned. I know in the Netherlands, it's very famous. We see pictures of your flood barriers all around the world, and there are these massive multi-billion US dollars, for instance, projects. And these kinds of interventions are very well known when it comes to floods. But when you just mention infrastructure for droughts, especially in the hardest hit regions, like you mentioned, say in areas like Africa, I wouldn't actually understand what someone might do in those regions to address this problem. So, what are the solutions available there?
Yeah, so you can build big reservoirs. Think of the Aswan Dam in Egypt, or the new Renaissance Dam they're building also upstream on the Nile. There's a massive reservoir operation. So these are the massive infrastructures. There's also a lot of local opportunities. So if you live I was visiting a family in Jordan there, and they collect the water on the roof, and they collect it in big underwater storage areas. So when it's raining, instead of letting the roof drain on the street and letting it go, like a lot of houses in the US, Canada, Europe do, they collect it actually and store it underground to be used in the dry season for their own domestic water use. So I think but building such a thing, I mean, digging the hole, making the infrastructure, waiting for the rain, I mean, it takes at least 2 years to have that established. If you look in terms of agriculture, you have this rainwater harvesting practices, and that basically, we've done some research on that in Utrecht. But what it shows is that, yeah, again, you have this wetter period, and instead of letting, because there's a lot of hill slopes, not letting the water run away, but trying to collect it with small little levees, like mostly it looks like ripples. It's not gigantic, but it's formed such an obstruction for the water that would have otherwise go downstream, and it infiltrates into the ground there, and that actually sparks new vegetation, and new vegetation sparks a little bit more shade, and that actually slowly builds an ecosystem that with more groundwater. And I think these kind of measures, I mean, you can't do that in 1 year. That's a multi-year process, but it is very important, and also in those regions. And then if you look indeed to other regions, yeah, you have reservoirs, you can do agricultural aspects, so like thinking of more sustainable irrigation, saving the water, not using as much, or even underground irrigation. I think we have here, which can also be used as drainage. And I think that's trying to be as effective as possible with that water.
And then getting to the international context. So I think it's really valuable to hear about how you've had these different experiences and have had the chance to directly experience the contrast between, say, the perception of a problem like drought in the Netherlands versus a country like Jordan. And especially regarding that, I know that some of the challenges that we've started to see on the whole when it comes to these climatic problems, when it comes to developing countries especially, and the divide between, say, the technology and the constraints that they have versus here in developed countries, the problems that are in public perception. It can sometimes be even really hard to identify the problem in the first place and make people aware of that from an outsider perspective. So, when it comes to these problems like droughts and floods and the perception of these issues, especially, what do you think we can do to, as scientists, as communicators, to increase the awareness of these issues in a more global context?
Yeah, I think it's very difficult because, yeah, we can share our science, we can talk about our science, but opening up the science, I think, is more important. So in that aspect, doing open science, which is a hot term nowadays, but basically not having your articles behind a paywall. If I give a presentation, then it should be out open for everybody to review, whether you live in South Africa or whether you live in the Netherlands. So opening up the science basically enables people to learn, because between universities there's quite a lot of interaction, but also to engineering companies who often actually make the solutions and actually implement the solutions. So also for them, to allow them to learn from the discoveries you've made, and vice versa, learn from their discoveries, and allow them to make, of course they have to make some money, but also implement that in other places. And by, if they have full access to the scientific literature, and also allow, have open discussion with university professors and everything, then I think that speeds up the process. There's of course all these implementation issues. They're gigantic in really getting the science to the spots, or really implementing things and going from pilots to real things. I think that's really challenging with all the policy that goes with that. But I think having open communication, open sharing of data, and open sharing of science, I think we can at least facilitate that process. And from a scientific point of view, that's one of the best things we can do, apart from talking a lot about drought and showing the good examples, but that doesn't reach everybody.
Yeah, I think the communication aspect is really important because sometimes we have this gap between people who might be extremely technical and knowledgeable about one very specialized discipline, but because of that, maybe they haven't had the opportunities as much to learn about communications with the public or take the time to do that, because I know how busy researchers can get sometimes. And regarding that last note, actually, I was very curious to hear about some of the links between the theoretical research being done and the practical applications, like translating, say, a model of what you predict droughts could be like in one country, and then getting that all the way to the infrastructure actually being built. And I know you briefly mentioned that policy is a big barrier there, and I can imagine the politics of the situation probably creates years and years of delay. Are there any other major challenges that you think prevent the theoretical research being applied?
Yeah, so first you need to prove that your theoretical research actually works. But if it's climate models, it's of course a slightly different thing. You give the climate projections and they go into climate projection of drought, and they go into policy. And the policy uptake is different country by country. One country is faster than another. We have a thing that's called the Delta program. There's a lot of knowledge uptake from the universities. But I think we're one of the few that really have that future-based water vision ahead. But that's also because of the unique situation. On the other hand, just getting that uptake, that really depends on either the political environment, the political parties in charge, but also the willingness and the urgency to have science implemented in policy for future. So a couple of droughts will help you to get drought through science into drought policy. And we just recently had 3 years, and there's a lot of motivation to really do something about the drought for the future here now. And the same is true for, I go back again to the California case, but in California, where there was 3 years of consecutive droughts, and you could see that the uptake of policy there was definitely enhanced by that. So unfortunately, often disaster has to happen before policy uptake is really accelerated. It's, at least we have plenty of examples showing that. I don't say that's always the case, but it definitely helps. And that's not always what you want. So I think that's one of the things. And the other thing is you really want to prove the solutions. And because it's a rare event, if you really made a solution that you think, okay, can help droughts, mitigate droughts, it's difficult because you need to prove it, and you need to prove it when there is a drought. For example, I do some irrigation improvements, and I show that it's reducing water availability, water use, but then I have to prove it in a real drought situation. When, I mean, that's the best proof of concept. But yeah, they are rare by nature, so they don't happen every year. So that also is a delay in a sense. Going from pilots and then upscaling, that's quite a big step. And that all takes time. And I think patience is key. The thing is that from a scientist point of view, I think we have to provide the science. So, and be willing to explain what we've done, how we've done, what the assumptions are that we've made, because science always has some assumptions and some setup. So I think being capable of doing that, actually actively doing, and spending time on that, which, because it costs a lot of time. And sometimes it's not as rewarding as writing a paper or doing a some presentation, but in the end, I think it's the bigger impact you can have. It comes with ups and downs. It's important to do for all scientists, and some people might like it better than others. And I think you should definitely also take that into account. But we should all try to show our results to the broader world, and by that hope that they get implemented as well. And if we can facilitate that, let's do that.
Yeah, I think it's just obvious, just with the immensity of the problem, how much this requires cooperation between companies who are, say, upscaling the initial pilots to the researchers who are starting the process to policymakers. So it really is a huge challenge. And the final area that I wanted to ask you about today was about the future of this. So, in one aspect, what I'm really curious about is when it comes to the future of this issue for scientists, what are some of the areas that we've historically seen are understudied or there still are research gaps in?
I think the link that we humans have with the process of drought and the link we humans have on the hydrological cycle. So yeah, precipitation falls into on the field, on the mountains, and eventually it ends up in the sea. I think we've all learned that in the textbooks, but the human component and the human role in this is quite significant. And how we manage our water and the individual decisions made on that level, I think that's way more important than we currently estimate. I mean, the volume of water that's stored in reservoirs is huge, and there's just a couple of people pressing the buttons of when to release these volumes. There's a big water use by farmers, there's big water consumption by industry, so all that taken into account. And I think, I mean, the number of naturalized rivers around the world, so rivers not affected by human reservoirs or any other kind of barriers, it's very small, especially in Europe and North America. And I think in that way we have a large impact and we need to capture that impact. So including the human thinking into our natural sciences here, or earth sciences in my case, that's a key challenge to really do that. But we're working on it. We haven't solved the problem, but we're making steps to better explaining things, and we can see that by including humans in our models, we actually do a better job in predicting current situations and also hopefully future situations. So yeah, I think that's one of the key aspects in terms of regions. I think the drought aspect is often considered as a continental scale problem because it's such a large phenomena. So I think that in that sense, most regions are covered. I mean, there's more focus on Europe and North America and Asia nowadays than there is on, particularly on South America, for example. But I think with global climate models, global hydrological models, all these more large scale models, that is being taken into account.
Yeah, I think that's a wonderful case for collaboration and especially interdisciplinary research. And then finally, on that note, when it comes to your perspective on this issue, just in general, what do you think needs to change in how you do this work or how people from NGOs, governments, everyone included, does this work as it comes to the worsening effects of climate change?
Yeah, I think you already gave the answer there, but interdisciplinary research, that's key to really understand the interactions between all the aspects and also to understand the processes that I, as an earth scientist, don't necessarily understand. So by having active collaborations already with people from other disciplines, I learn a lot. I hope they also learn something from me. I think in the end, we get a better overview of the situation and a better overview of what climate change can do in terms of droughts, water resources around the world. And you can only do that also. I mean, I'm not talking into the scenario between scientists, but also listening indeed to other stakeholders.
Yeah, I think that's very fascinating and definitely is an insightful call to action at the end. So finally, if someone is more interested to learn about your work, where should they go?
They can go to my profile page at the University of Utrecht or on Twitter, where I normally share most of my research, and that's at Niko Wanders. So you can just find all my research there.
All right, I'll be sure to include those links. And thank you again for your nuanced perspectives and focusing on all the different contexts that you can look at this issue through.